Welcome to Microwave Engineering lecture series. In this lecture, we are discussing about the general theory of transmission line equations. So in last part, we have seen the first part of the equation. Now we'll complete the remaining equation parts. In last lecture, we have discussed till the equation 9 and 10. Now we'll take this current equation. In this current equation, now we'll take this z into this here. So we will simplify this equation in the form of I is equal to a by z into we will get the remaining term of root of z by to the power of zys minus b into 2 to the power of zy. This y divided by b by z we get again e2 to the power of minus zy into s. So now we get these two equations. Whatever I discussed already, this a current equation and then this voltage equation. By simplifying this term, after simplifying the z's and root z into z, so we'll take this root z into inside this root. So we get the solution of y by z into e to the power of root of zys minus b into root to the power of yz e to the power of minus zys. So we get this two equation of current and voltage equation, and now for the we are calculating a distance receiving end condition. So we make ss and 0. After making this ss and 0, this s should be here. So we make this e power 0 s will become 0. So e power 0 will become as 1. So we get only this arbitrary terms of a into root y z minus b into root y z, and then for a current equation er equal to c into yz y by z. Sorry, here we have to get the z by y condition. Sorry, z by y minus d into z by y condition. So and now we know this characteristics impedance already we have discussed in previous lecture series. So we get this z naught is equal to r plus j omega l divided by g plus j omega c. Considering this r and g as a negligible resistance, so we cancel this, will become 0. So we get this nothing but L by C, that is nothing but root of impedance by admittance condition, and ZR is equal to voltage ER by IR. So based on this we get the four arbitrary equation by simplifying. In previous lecture we have seen the arbitrary equation of a plus a b c d. So after substituting this equations we get a is equal to ER into root of into 1 plus z naught by zr. So this four arbitrary condition we get this. Now here we can see this we get the two equation, and now we'll take this, and E is equal to ER into 1 plus z naught by zr, because we have taken the receiving end condition. We have taken z naught by zr into this equation of arbitrary condition this instead of a plus b. We have replaced this equation by taking this LCM of zr. We get this 1 plus z naught by zr is nothing but zr plus z naught divided by into zr equation. So after simplifying this equation we get this two equation of current and voltage is equation as E is equal to ER into z naught zr plus z naught divided by 2 into zr, this multiplying, and then here after simplifying we take this equation down here, and so this two equation 20 and 21 is nothing but the general solution equation. And there is another way of representing this equation, that is nothing but we multiply this z naught and zr inside this equation. So what happens is here we get this z naught plus zr plus z naught zr minus z naught. So we get the four equations here, and by solving this equation we get this, like we get the equation of in the form of this E is equal to ER into e to the power of root of zys plus e to the power of minus zy into s by 2. And similarly this term is also, by resolving this plus and minus condition we get this thing, and we get here you can see this condition. So and by solving this we consider this e power zy s plus e to the power of minus zys by 2 as in cos h into gamma l. This term we consider as an propagation constant. So here this e power root of zys plus e to the power of minus root of z by s2 we have mentioned as in cos h to the power of zy into s, and similarly for y term is also we have mentioned as sin h into root to the power of minus z root to the power of zy into s. So by putting this term into this equation, we get this two general solution equation of E is equal to er cos h root to the power of zy into s, and plus ir z naught into sin h into root to the power of zy into s. And we mentioned this root of zy as and gamma. So we'll get this E is equal to er into cos h gamma s plus ir into z naught divided into sin h gamma s condition. So, and similarly we get arrive this current equation. So this is a general solution equation. Thanks for watching. In next lecture series we'll discuss about the waveform distortions.